Consider the function f of x, which is equal to minus brackets x minus 6 times brackets x minus 3. Use upper and lower sums to show that the following definite integral is negative. The definite integral from 1 to 9 over 2 of f of x dx. Okay. I'll sketch the function first, and I'll have a better idea of what's going on. It's a quadratic. If I expand it out, I'll get a minus x squared at the front, so it's a quadratic that faces downwards, and it has x-intercepts at 6 and 3. So it's going to be mostly negative. So I'll just do the y-axis here. So 1, 2, 3, 4, 5, 6. It has x-intercepts at 3 and 6, and it would go like that sort of thing. Okay. So 9 over 2 is 4.5. 3, 4.5. Oh, that's halfway, which means it must be the vertex. The vertex is always halfway between the two intercepts. So that's kind of convenient. Okay. And the integral I'm looking for is from 1 to 9 over 2. So this is 1. So that goes down. 9 over 2 is that number there. So that's the integral I'm looking for. And I'm supposed to show that that's negative. It certainly looks negative. The negative part here certainly looks bigger than the positive part, but I might have drawn it a bit badly. So I can't really be sure based on my picture, but my instinct's telling me that that's pretty good. Now I'm supposed to use upper and lower sums. Well, negative means that it's less than 0, and the upper sum is always something bigger than it. So if I could show that the upper sum was 0, or even upper sum being negative, then this thing, because it's less than the upper sum, would have to be less than that negative number and therefore also be negative. So I could find an upper sum. Okay, so what if I use this interval here? Because then the upper sum would be this box here. Because that's where the maximum is. So to figure out the upper sum, I'm going to need to know how wide this is. So that goes from 3 to 9 over 2. 9 over 2 is, well, I can look at it. It's 1.5, isn't it? Which is 3 over 2. And then I need to know this height. So first I'll figure out what f of 9 over 2 would be minus 9 over 2 minus 6 times 9 over 2 minus 3. Okay, well, the 9 over 2 is 4.5, and minus 3 was 3.5, 3 halves. We already figured that out. That's 1.5. And the 6 is the same distance away. So 9 over 2 minus 6 will be a negative number. It'll be minus 3 over 2. Okay, and so minus times minus is plus. 3 times 3 is 9. 2 times 2 is 4. 9 over 4. Okay, so I can figure out this box, this upper rectangle, as part of my upper sum. So that's going to be 9 over 4 times 3 over 2, which is 27 over 8. 27 is more than 3 times 8, which is 24. 4 times 8 is 32. So 27 over 8 is going to be a bit less than 4. So if I could show that this bit was a bit more than negative 4, I might be able to do it. I'm sorry, a bit less than negative 4. Okay. If I did an upper sum on this side here, well, the maximum's 0, and so it would just come out to 0, and so that wouldn't show me that my upper sum's negative. So I need to cut this into smaller pieces. I'm just going to hope that if I cut it into these two that it works, because that would be like this and this. So that one, the maximum's 0, but this one, if the maximum was low enough, then I might be okay. So let me figure out what f of 2 is. F of 2 is minus 2 minus 6 times 2 minus 3. And 2 minus 6 is negative 4. 2 minus 3 is negative 1. Minus, 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 that means the answer is still negative 4. We're doing well. So this one will be minus 4 times 1. This one will be 0. And the minus 4 is going to be bigger negative than this is positive, so it's all going to work out right. Okay, so this is my upper sum here. Okay, so I'm doing the upper sum on the subintervals from 1 to 2, and from 2 to 3, and from 3 to 9/2. And the first one is the maximum on that interval is -4, and then times 1, because that's how wide it is. The maximum on the second interval is 0, and then times 1, because that's how wide it is. And then the maximum on this interval is 9/4, and then times 3/2, because that's how wide it is. And so this comes out to -4 plus 0 plus 27/8. And 27/8 is less than 4. So this is going to be less than -4 plus 4, which is 0. So therefore, this upper sum is less than 0, because it comes out to this thing, which is less than this thing, which is 0. Okay, so finally, let's see. So I know that from 1 to 9/2 of f of x dx is less than the upper sum. This upper sum, and this upper sum is less than 0. So therefore, the integral is negative. Cool. I managed to use a upper sum on 3 intervals that aren't all the same width to show that this integral is definitely negative.